Hey everyone, welcome to our panel session, Proactively Improving Monitoring and Reliability with Chaos Engineering. I'm Jason Yee. I am the Director of Advocacy at Gremlin, also formerly an evangelist at Datadog. And today I'm joined by a bunch of amazing people. So without further ado, let's get into some introductions. First up, I'd like to introduce Tay Nishimura. Tay, why don't you introduce yourself and tell us a little bit more about what you do at Datadog?
For sure. My name is Tay. I work as a chaos engineer at Datadog, and previous to this, I was an application engineer for about 5 years. Here, I work primarily on tooling and game days, so being able to inject disruptions into a staging or production environment.
Awesome. We'll dive a little bit more into especially game days, because I know that's going to be an interesting topic to our viewers. Up next, Mauricio Galdieri. Mauricio, why don't you tell us a little bit more about yourself?
Cool. Hi, everyone. It's nice to be here, and it's an honor to be sharing this panel with such great people. I'm a software architect here at Pismo. I work at a squad called a staff engineering squad. We try to build the foundation for with toolings and best practices for other squads to build their products on it. And right now I'm working in building this engineering chaos engineering culture inside the organization.
Awesome. Fantastic. And last but not least, we have Kolton Andrus. Kolton, why don't you tell us more about yourself?
Good afternoon, or morning, or evening, or night, wherever you're at. Great opportunity to be here. Very, very honored to participate. My name is Kolton Andrus. I'm the CEO and founder of Gremlin. Before I was a CEO, I was a software engineer at Amazon and Netflix. Unfortunately, the chaos engineering title hadn't been created yet, and chaos engineering was just building systems correctly back then. But I've been doing this for a little over the last decade, and it's something I love and want to see and help other folks get better at.
So I think that's probably a really good starting off point, right? Kolton, you've got such a history with chaos engineering and where it's come from, probably more than most given your experience. So I'm curious if you could give us a little bit more insight about what were things like in the early days and how have you seen things evolve?
Yeah, I was thinking about this a little bit this morning because when I was at Amazon, it was every engineer's responsibility to build reliable code, to build performant code, to build quality code. And so it wasn't one team's problem, it was everyone's problem. And I was earlier in my career as an engineer, I was on a team with 5 PMs that were tasked for solving this problem. And what we did was mostly postmortems and game days to help people prepare and understand. And pretty quickly, what we realized is there was some tooling that could help us a lot. Can we automate this? Can we add some safety features? Can we build it in a way that people can approach it and understand it so that they're willing to use it? And we had a lot of success with that. I will say we got a lot of the same headwinds that folks probably get today. Oh, we have too much chaos. Oh, my system works great. Oh, nothing's ever going to go wrong. I'm too busy. I've got to get this feature done. But at the end of the day, the folks that invested the time got time back, felt more confident in their systems, and felt better about themselves as engineers. And that really, so I had that opportunity at Amazon. Toward the end of my time at Amazon, Netflix launched Chaos Monkey. And it was great to see that public support, really, to see folks speak out and say, hey, we believe this is important. We think this is interesting. We're going to invest time in it. Because 2009, you Google this and you don't find anything. There's 5 papers out there. There's very little reading material. We were on our own figuring it a lot out. And that's one thing that's been great to see cascade over the last decade is many more folks sharing their thoughts and ideas and really that growth and maturation of the space.
I like how you said that it became part of the culture, and it was only then that you started looking into tooling and realizing that could make it easier and really help advance that culture. Mauricio, you mentioned in your introduction that you're really at that point of building this culture of reliability and adopting game days. Tell us a little bit more about how that process has been for you. Where did you start and where are you at now?
Cool. We're just starting in this whole engineering practice here. We've been into this for like about 8 months for now, and it's been very interesting because it's before I started working with chaos engineering here at Pismo. I already had heard about the terms. I already had read a lot about it and talked to people about this. But and although this whole concept it's almost 10 years old now, it's still not quite understood. It's difficult to get people buy into this whole chaos engineering practice, this has been the most difficult part here. I mean, the technical part is it's easy to get running. It's easy to get the agents running. We have excellent tooling, and that's easy to use and configure and so on. But to get people understand what is the value of running chaos experiments, I think this is the most difficult part here. And I think it all boils down to people still think about chaos sessions and chaos experiments as just another form of an integration test, And when you put things this way, the tasks that are chaos related, they start competing with other task teams that have on their backlogs. And if you think about chaos experiments as an integration test, another form of integration test, it gets lower and lower priority against those other tests. So I think this is the most difficult part to put things moving here. But then we start realizing that this is not a technical challenge. It is almost an educational challenge. You need to educate people into this chaos culture. And this has been a great ride we're going through here, and it's a fantastic challenge here. And I really like to know a little bit more about how things went in companies that already went through all of this. I'm sure Datadog has gone through this phase, and it would be interesting to hear their story too.
Yeah, that's a fantastic segue to Tay. How have things been at Datadog? How have things progressed, and where are you at now?
Yeah, for sure. Given uptime is really important to the Datadog product, we monitor. So if we're down, people can't see what's down in their systems. Chaos was something we looked at pretty early on, and we had guilds around it. We were killing random instances. There came a point where we started dedicating a team to it, but before that, it was very much grassroots. I think we went through the same growing pains that Mauricio mentioned in his segment. Now we still have those problems, but at a larger scale. So taking down an entire availability zone's worth of network, because no matter how resilient we are, we also have to handle the failure of the cloud underneath us. And right now we're trying to identify what kind of triggers should make people think of game days. For example, if we're looking at a gnarly postmortem, we try to ask ourselves, could we have game date this, or can we game date this in the future? Also, we're going through a lot of scale. So there we want to think of ways that we can sort of use the disruptions or experiments, whatever you choose to call them, as a regression test, because what worked last month might not work this month with the scale or the customers that you have today. And by regularly injecting your system on a cadence, you can make sure that your system is still as resilient as when you had designed it.
Absolutely. That's a fantastic point about checking for that regression, right? I think there's a delicate balance between what Mauricio was saying about thinking of it as tests, and sometimes that can be a negative, but also doing this recurring testing so that you don't regress. I know, Kolton, you've chatted a lot about automating chaos, and that's some of what Netflix had done and the work you did there. Any thoughts on the process of moving from manual game days to automation and what people should be considering?
Yeah, I mean, I think there's been a common pattern that I've seen across companies as they mature in this space. It's one, they have to get comfortable with the idea, and that people have to be bought in, not just on the engineering level, but on the leadership level. We talked a little bit about that, but why is it hard? Mauricio touched on this. It's how you quantify the value of the outage that didn't occur. And if you're a large, I don't know, maybe social media platform that had a big outage in the last 3 weeks that was worth 66 million, if you could go back in time and prevent that from occurring, could you convince anyone that that was a $66 million fix? My guess is not. And that's part of the problem, because it can have a huge impact when it goes wrong. But when things go right, it's like you didn't even know that they happened. And so people know this. They want to start out small. They want to go out and do some testing. Let's do some easy things, reboot some hosts. Really, they're learning about their system, and they're doing exploratory work. They're uncovering unknown unknowns. They're better understanding their dependencies. That's really good engineering. It helps you become familiar with the system and how it operates. It forces you to talk to your dependencies and the teams and understand their expectations and make sure you're accounting for those. But then you hit a bit of a threshold. Some teams are good at that. Some teams are not. How do you get the organization as a whole to embrace this and to see the value of it? And that's where you have to have some standards. Some of my most successful customers or companies I've seen have a deploy threshold. If you want to deploy into production, you have to prove that you can withstand a set of failures. And that becomes part of the build and deploy pipeline. And similar to how you mentioned, Jason, as testing, that can be a pro and a con. It can block work and slow you down, but it can also prevent you from redeploying a failure you've encountered in the past. And so I've seen that type of maturity curve a few times. And it's exciting when folks get to the point where they're past some of that exploratory work, because it's still happening and that's still valuable for the engineers. But the organization starts to benefit more broadly because those checks and balances are in place.
I like that point of using chaos engineering and using this as a threshold of when things can get deployed. And I know that Datadog has some of those concepts as well, particularly around ensuring that metrics and monitoring and alerting is all in place. Tay, could you tell us a little bit more about how that works at Datadog?
Yeah, for sure. So we've been driving what we call production readiness, where we have a series of expectations for new systems that are coming into production. Now, that's not something we retroactively apply on systems that already exist. So we also run system risk reviews where we make sure that we are aware of the risks that we see. And a lot of that is SRE work. So we are trying to, as much as possible, again, we want consent. It's a very bottom-up organization. We want consent from the team, but we try to encourage, as experts, these are the experiments that you can run in order to make sure that your system does not have this dependency issue in production. A lot of that has not made it into production yet. So that's something we're still working on, is how do we make users feel safe in production? Users being the internal Datadogs that are building systems for our customers. And how do we make sure that we don't accidentally cause an outage that makes customer impact, which is very, very important for us.
And I guess along with that, then, are there certain metrics or alerting or observability pieces that you're starting to require?
Yeah, sure. Maybe I could give an example of a experiment that we're trying to design right now. So we used to have very varied caches across our whole organization, as in every team made their own cache. And right now we're creating a product internally that allows all teams to plug into a single cache setup and they can get their own deployment. But one thing we want to be careful of that we learned through trial and error is even if your team doesn't think it's depending on the cache and it's not supposed to be durable, over time, you tend to, if nothing goes wrong for some time, you tend to assume it's going to be there. And it's very explicit, even in the name of the team, that this cache is not supposed to be durable. So the intention is that even in production, we will break the availability of the cache up to the SLO, whether it be 4 nines or 5 nines, in order to make sure that the application is confident that they are not depending on it, not just in the design doc that was written 3 months ago, but now. And we will add monitoring to that. But one thing that you have to be careful of there is that you don't inject a failure when there's other natural failures going on and accidentally topple the whole system. So we also need to be aware to put in readiness checks and make sure we're injecting when the system is healthy.
You mentioned a few things there that I think are probably worth diving into. And so I'm going to pitch this question at Mauricio. Particularly, you mentioned, Tay, SLOs. And Mauricio, I know you're building out not just chaos engineering, but you're really developing the reliability engineering arm of Pismo. Talk to me a little bit more about some of the metrics that you're using to measure your reliability and ensure that you're improving on that.
Cool. Our industry, it's a very critical one because we at the end of the day, we deal with other people's money. So we need to be extremely reliable and extremely, we have very stringent SLAs and so on. And we have an additional challenge because although we're a global platform, we also need to comply to local regulations. So we need to have local installations of our platform and so on. We have several levels of metrics we need to take into account, and they're not just infrastructure metrics, but also we have lots of business level metrics we need to have. I mean, there are certain files that need to be generated, certain events that need to be generated. We have to make sure they're generated. We have several integrity checks in place, so we have to make sure that all the integrity checks and all the steps are necessary to check the whole integrity of the process went okay. So we need to have several levels of metrics. So we use some ESTO metrics like response time, response codes, and so on. But also we have to read lots of log metrics and custom metrics based on log lines, because there is where we have the business logic being exposed as metrics. So we do lots of log monitoring and lots of tracing and span monitoring also. So we need to make sure we have the business level of those metrics and monitors covered.
Excellent. Kolton, I'm going to pitch the same question to you, right? What are you looking at as you think of reliability and really measuring chaos engineering and the organization?
It's an interesting question because you get two different answers based on which hat I put on. From an SRE, I'm following the traffic. I want to see it hit the front door. I want to see it hit the proxy. I want to see it hit the API. I want to fan it out. I want to see the P90s. I want to see the P99s. I want latency. I want CPU. I want disk. I want it all, but I want to distill it down to something actionable. What is the first thing that's going to fall over? How am I going to know? What's really going to help me diagnose it more quickly? How can I quickly narrow the hundreds of variables of what could be impacted down to a couple so that we can find the source of the failure? When I talk about business ownership, actually, one of the ways you phrased it to Mauricio sounded correct. It's about reliability. It's not about chaos. When you're going to sell your CEO, your CTO, your CFO, whoever owns support, the people that are feeling the pain when there's an outage because there's lost revenue, because customers are unhappy, because a customer doesn't renew, or whatever the impact to the business is, those are key drivers for why we have jobs, for why we invest in chaos engineering. And ultimately, they don't want to hear about chaos. They don't want to hear about breaking stuff. What they want to hear about is reliable systems and how you're going to accomplish that. And so to me, what is a reliable system? Well, there's how we accomplish that and what is reliable. So we talked a bit about how we measure the reliability of the system, but how do we measure the reliability of the team? Have they done on-call training? Do they have a good dashboard? Do they test their alerts and their engagement? It's silly, but I've seen a number of outages where someone just didn't get paged and it was 15 minutes longer than it needed to be. Are they running game days? Probably in the beginning. Do they have a set of automated tests? And then we can get into some of the specifics. We're all building distributed systems. Do you know all of your dependencies? Do you know what happens when one of your dependencies fails? And do you know what happens when one of your dependencies slows down? Tay also hit on another great one, region and zone evacuation. We must assume that the cloud is ephemeral and parts of it could go away. And gone are the days of the old S1 where we wrote up a business plan about failing over region. Welcome to the new world. Netflix set the standard. You should be able to prove that you can evacuate a region in minutes, not hours or days.
I like that point of assuming that the cloud is not stable, right? I think that's something that a lot of people miss is if you go back to a lot of those early Netflix writings about why they did chaos engineering, it was purely based on the fact that AWS was brand new and they're like, we know this thing cannot be trusted. So that's always a good reminder. There's a question that came in from chat. Go ahead.
Sorry, Jason, I think there's a little more than that too. It's not just that, we should not trust the cloud providers or they're immature. It's the simple fact that failure will occur at some level, at some scale. Some failure is going to slip through. We cannot catch everything. The sun would burn out if we tried to test all combinations of things in advance. And so some things will happen as a necessity of running a business and taking a reasonable amount of risk, but we can mitigate that risk. One anti-pattern I see is my cloud provider failed, so I told all my customers it was their fault. That to me is passing the buck. And so, yes, we should assume that the cloud providers were failed, not because they're doing a bad job, but because that's just the world that we live in.
Absolutely. I love that idea of not passing the buck, right? And being responsible, because ultimately, especially if you're like Mauricio in a regulated industry, or if you're in travel, there's a bunch of regulatory fines that you might be facing, and you can't just say oh, it's Amazon's fault, send them the bill, because that's just not going to happen. So I wanted to bring up, there was a question referring back to the SLOs, and it's mostly for Tay, I think, because of how you mentioned that Datadog will break things up until the point, or up until the SLO. And so Graham's question from the chat is, how do you get that precise?
So we are still, I'll be very honest, we are still in the experimental phase of this. I'm sure sometimes we'll go over and under, but being able to measure it is number one, making sure that you know what your current SLI is. And then from there, I believe there is a phase where you experiment. So you want to be able to see the impact of a outage or an experiment that you apply, and then you want to measure the impact that it has. But in our case, because it's a cache, you can introduce a certain amount of bad responses, and that's something you can measure as a percentage. So another way that we look at it is in terms of time. If we expect that the cache goes down and the user being the engineer in Datadog, the user be able to respond well to it, then we just turn off the cache for a certain period of time with a network disruption or what have you.
Cool. I think that question is a good one, and it leads to the larger question that I get asked a lot. And so I'm going to turn this question around to all of you. Often there's the question of, or the statement of, I'm afraid to do this in production, right? And I think we've all experienced that of, it's scary. And so when I teach people about chaos engineering, there's the notion of, well, you should set abort conditions. You should set a threshold at which point you say, that's too much, let's roll back. But oftentimes then the question is, how do you set those? Where are your thresholds? Mauricio, I think you're probably in the most regulated industry out of all of our guests here. How do you define your experiments and set those conditions to ensure that they're safe?
Yeah, I think this is pretty much in line with what Tay said, and we're working here with the concept of the our error budget. So we're trying to build this notion, this concept of an error budget that we have, and we have some level of error, some percentage of errors that we should use in order to experiment with the system and so on. We're not there yet as to go into production, because I think it's something that you build slowly. Chaos experiments are all about building confidence in your system, but you first need to build confidence in the process itself. And we're still building this kind of confidence. So we're still experimenting, seeing how when we reach our SLOs and in sandbox environments, we do have this environment where our clients connect to and integrate with us and do their tests. So it's kind of a live environment, it's a pre-production environment. So it's a safe place to practice this, because it's not that critical if we go over what we intend to do. But it's something that we have to experiment. There's no silver bullet for this. You have to experiment. You have to see where you can push your experiments into. So these regulations and those legislations actually help us in that, because we have to comply with a certain level of service. This is not only for because we have this in our contracts, because we have to comply with local legislations also. So this actually helps us to set this threshold, this line that says where we cannot go further than that, and this helps us build this error budget concept here.
If I could add to that, Jason, I'm realizing there may have been a little more nuance in the previous question than I realized. So I would definitely recommend, as Mauricio was saying, playing it much safer in production. Like if you haven't gotten a disruption to healthily run in staging for some frequency, you probably don't want production to be where you try it out. I know that different companies silo the traffic differently in order to do this, but we tend to apply it to the whole system. So we would definitely experiment first in staging. And then once we see that it's healthy and safe, we may do, one more 9 than what we were testing and staging. But definitely testing in the environment that you are deployed to is very important, because there are some things that are only rolled out to staging environment, and there's just so many environmental factors, even in the availability zones that you're in, that could be subtly different. We operate on Kubernetes, so if the Kubernetes version is different between staging and production, even that could cause unexpected changes to how the network behaves.
Kolton, any thoughts on the same question?
Yeah, I guess without giving my personal opinion on SLOs, I think that how do you get to doing chaos engineering and production safely? Yes, you need to mitigate risk along the way. What we're doing is mitigating risk, and so you should absolutely start in your local environment, then your staging environment, then a pre-prod if you have it, before you go to production. I completely align there. I think one important point I will mention is, while production is scary, staging never looks like production. The type of traffic, the magnitude of traffic, the network routing, the configuration, the load balancing, the timeouts, the thread pools, all of those tend to be different in production. And so you can choose to delay testing production until you feel ready, and you should. You should do it safely, you should do it thoughtfully, but there are a class of failures you will never find in staging.
Absolutely. Staging is never the same as production. I think Tay brought up an interesting point, though, along with that, right, is because things are different, you do want to test in all of them. So I think oftentimes we think of it as a progression towards production. And ultimately, yes, we want to get there, but the notion of let's test our staging environment, because if you break staging, while it may not affect your customers, for a company the size of Datadog, I'm sure that it just brings all of development work to a halt.
Yeah, that's very true. We started doing these things we call large-scale game days, which are where the zonal failures and such have been introduced. And last December, I ran the instructions that caused us to break a staging cluster that everyone is on for 7 hours or so, and we did find learnings from it, right? Like we couldn't resolve it because we didn't know some things about our environment, mostly around how we were using Cilium. And so that was a great learning, but it was 7 hours of staging time on a late Thursday, early Friday that other people couldn't use. And so if you do this every week, you're certainly going to, get some judgmental eyeballs on your team if you're not careful about letting people know, hey, we're going to break this in staging. Here are the ways that you can brace for it. So if you're a team that's working on an application and you have downstream clients, they have to know that this is going to happen to them, or they could be spending hours trying to figure out how this one engineer's code change affected their environment so heavily. So we tried to build a culture of being mindful of other engineers, and this translates directly into production as well, for sure. And it may be easier to game day certain systems like an ephemeral cache over the central service that's ingesting all of the metrics at the very front of the pipeline. There's a lot more conversations that need to go into that.
Kolton, I think you had something that you wanted to add to that.
Yeah, I mean, well, what we're talking about is an interesting balance of how much pain do we need to subject engineering to so they pay attention, because failing the cache to hit the SLO and rebooting the servers underneath them at Netflix, that was a social pressure to make sure that people didn't ignore it because the business felt like it could not be ignored. But if you do it too much too often, you're going to have a mutiny on your hands. And so I think it's interesting, just I wanted to touch on that explicit balance of there's no friction, then like people will just ship feature work and ignore it, or most will, some won't. And if there's too much friction, then like they can't get work done. And so what's that 80-20?
I think it also brings up an interesting point of that a lot of that tends to happen when I think you have a dedicated chaos engineering team or SRE team that's doing the chaos engineering. And so there's a little bit less of that ownership, right? Because now it's another team is inflicting this pain on me versus me owning my service and doing it to myself. Mauricio, I think you had mentioned, starting to build a culture where your service teams are adopting this. So I'm curious if you've got any tips for how you've done that, and if you've seen any increase in the ownership of reliability because of that.
Yeah, this is the hardest part, I think, because as I said, we have. I see here that we have 3 potential blockers in building this chaos engineering culture here. One of them is going past excitement. Doing chaos engineering and running chaos sessions is lots of fun. It's fun to break havoc in your system and so on. But this you have to go past this. You have to have some kind of structure, and you have to analyze your results. You have to write down your hypotheses and so on. You have to plan ahead. And this leads to the second blocker, which is gaining engagement from the teams involved. So as I said before, you have to make sure people understand what chaos engineer is all about and understand the real value of running those chaos sessions. And then the third blocker would be to go into production, I think. it's very hard to sell this inside the organization, mainly because we work in the financial industry, so it's very critical to go into production with this. People are afraid to go into production with chaos engineering, so you have to build this slowly. So I think before we think about building a team that owns the chaos engineering process, I think we have to build this chaos engineering culture, and this boils down to build a resilience first culture here. I mean, we do have several levels of monitoring and resilience in place. We have several integrity checks from source code to alarms and so on. We have several levels that make sure we are running as smoothly as possible. But I think this chaos engineering has to go one step further, because experimenting with chaos sessions makes you learn new things about your system, learn new things on how it's going to break in production. This we cannot know beforehand. This is something that we'll only know when the outages happen. So I think more important than building ownership of the process itself is to build this culture of chaos engineering. And I think the owning of the process itself can be mostly automated. So this could, at the end of the day, they may be owned by the SRE team, maybe. But most of those sessions automated. We need to build this culture of being able to navigate complexity and so on, because as we come up with more features in our platform, it gets more complex, and it gets even harder to know how the system is going to break in production. So I think the ownership of the process, I think everyone should own the resilience concept and the resilient processes involved.
Mauricio, you said something in there that I think was really fantastic, and that's that you'll learn things that you didn't expect, right? You learn things that just come up naturally in a system, and I think it dovetails nicely to a question that we got in the chat, of talking about, can you talk about some takeaways you've seen working with all the experiments and companies and teams? And I think maybe Kolton would be a good fit to answer this, because you've now with Gremlin worked with dozens of different companies in implementing chaos engineering. Can you share some of what you've seen from the learnings of those companies and broader experience?
It's a little bit of a vague question. There's a lot of learnings. What do I think is most important? I think I'm going to reemphasize something Mauricio said around that confidence in deploying to production. Like some of the customers I have, they're in the financial services industry. They care a lot about the regulatory compliance. They want to self-detect. They want to self-repair. They want to ensure that those things aren't occurring. And so that's where that best practice of you have to meet this deploy criteria before you can go into production came from. And I think that's a healthy evolution. I think another one that I've seen is it's really about accountability. And I loved again what Mauricio had to say there. But who's accountable? And I think there's a discussion that needs to be had about accountability, that it's not mutually exclusive with blameless postmortems. We don't have to blame engineers for process and system failures, but that doesn't mean it's okay that we had a large outage. It doesn't mean there aren't things we can learn. It doesn't mean that we shouldn't take that information and factor it back into our planning, so we're investing and we're preparing for it. And I'm going to be on the side of the engineer here. Usually it's leadership that is choosing not to invest in these type of efforts and in favor of chasing the latest feature or whatever deadline or whatever thing needs to be done. So what are ways we can get accountability? You can have an SRE team that shows up at your desk and yells at you. I don't think that's the most effective way. I think, as we've discussed, that culture that it's everyone's problem and everyone's responsibility is far more effective. To do that, you have to give the tooling and you have to give the kudos when good work is happening. I don't think this industry recognizes that a boring system that doesn't fail doesn't happen for free. It's a lot of hard work. It doesn't happen because you get lucky. people don't get promoted. They don't get recognized for that work. We see the firefighters. We see the folks fixing the things that went tragically wrong. Do we see the folks that are doing just good, heavy work every day? Another pattern that's successful in that vein of accountability is if an outage has been caused, the outage and the postmortem are not complete until you have proved that you can withstand that outage again. And so, yes, we talk about it. We get the timeline together. We get the teams in the room. We talk about the process, the system, the people, what could do better. And then we go out and we run a game day or an experiment that shows that we fixed the things. And that one, to me, it strikes home because I've seen a lot of bug fixes and outage learnings go into Jira to die instead of being properly followed back on.
Yeah, or even if they do get done, right? I was going to say, even if they do get done, sometimes the fix doesn't actually fix it, right? We have these suspicions of what will actually fix things. Tay, I'll let you go, and I will tack on one last thing since we have about 4 minutes left. So I'll let you say what you wanted and then add on what's the one thing that you want people to take away and actually go do from this.
I mean, I think they can be one and the same. So to echo what Kolton was saying, what Mauricio was saying about the individuals on the teams who applied the chaos and then tried to fix the problem and then reapplied the chaos and proved, celebrating those successes, I think, is really, really important, especially when someone makes the effort to realize, oh, this outage we had the other day would not have been the lowest severity. It would have been the highest severity unless we had done that one game day in May. I heard a story like that the other day, and it made me very proud, but it also makes the organization proud. I think that chaos is scariest before it's done. But once you have applied it and it has worked and you know that your system is doing well, it is actually very encouraging, very exciting, and having a lot, like, I think in staging, we have 3,000 automated disruptions in a week. That boosts confidence. So it's all about confidence doesn't happen overnight. It's built. How do we boost each other's confidence?
Awesome. So yeah, let's go around real quickly in the last couple minutes that we've got left. What's one thing that our viewers should do from each of you to adopt chaos engineering? So Tay, we'll start with you.
Yeah, try one. There's a lot of tooling out there that wasn't available a decade ago. Just go try one. The chaos community is really open and friendly to newcomers. So go ahead, do a small one, see how it goes, see how you feel. If you feel more confident, then try again.
Awesome. Mauricio?
Yeah, I think people should realize that chaos engineering is all about confidence. Not only confidence on your system, but also confidence in your processes, and confidence in your engineering team, confidence in your monitoring strategies, and so on. And this also goes back to our clients also, because I'm seeing our clients being more and more interested in how we're running chaos engineering here and what are the results. So this also builds confidence with our clients also. So I think the greatest takeaway here is that it's to realize that chaos engineering is all about confidence.
I'll just dovetail off of that. Like one of the things that I get said to me a lot that people think is funny is, hey, we're not ready. We've got too much chaos. We don't know where to begin. But if you're not ready because there's too much chaos, then it's kind of like saying, I want to lose 10 pounds before I start going to the gym. Like, chaos engineering is the way to tame the chaos. Chaos engineering is the way to better understand your system and stop firefighting. And so if you're waiting for some magical threshold before you begin it, the answer is pick up the dumbbell and start doing curls. Like, start somewhere and get familiar, and you'll get better. The other one is a classic programming adage that hours of design can save you from weeks of coding. And I think that applies in the chaos engineering space. Minutes of chaos engineering can save you from hours of downtime.
Awesome. Well, I'd like to thank all of our guests. This is a fantastic conversation. Just to dovetail onto Tay's last answer about the chaos engineering community, highly recommend that people join that. You can go to gremlin.com/community and sign up for the Slack there. There are over 8,000 community members that are chatting and sharing stories about chaos engineering. So I invite you to all join us, and thanks for coming.